Hi, Beth and Sam. This is our second example of the day. I hope you enjoy it. Okay. Oh, Alistair. Sorry, I forgot about you, Alistair. How could I forget? No, I do. All right. Here we go. Here's our second example of the day. We've got to graph 1 over x and 4x and find the area between the curves from 1/4 to 1. Now, the important one about this is it swaps over. Okay? That is, for one part of the graph, for one part of the situation, one graph's on top of the other, and then they swap over. So you have to do two separate area calculations. First things first, we've got to graph those two on the same set of axes. So let's have a look at that. We're going to go, I'll just start a new page here. And let's add graphs. Add graphs. Right, so first graph I'm going to put in is 1 over x. Return. So that's it. And then Control G allows me to put another graph in. And the other graph is 4x. And enter. So there we are. There's the two graphs there. Now, it's not much good to us at the moment because we only want to work out the area from 1/4, okay, to 1. That's the area we want to find out. The area between those two graphs from 1/4 to 1. So I don't need all that space. And this is what I've mentioned before about changing the window. So if we go to menu, we go to menu here. And window settings. I don't need all that wasted space. I'm actually going to have my x minimum as 0. My x maximum, I'm going to change to 1. I'll leave everything else the same just for a moment and see how that looks. Aha, that's much better. Okay, I've now focused on the part of the graph that I'm after. Okay, from 0 to 1. Now I'm after the area between the graphs from 1/4 to 1. Okay, in fact what I might do is just actually limit it to that. So I'm going to go back to menu instead of 0 to 1. We're actually going to go from Windows settings here. I'm going to make my x minimum 0.25 because that's the only part of the graph I'm interested in. Now, do you notice how it swaps over? There's two different areas. We're going to find the area between the graphs. So if I just use my pen here. I've never done this before. This is good. We're going to find this area here. This is cool. Okay, and also this area. If I change colour, something else. We're going to find this area here as well. See, we're going to find two areas. It's the area between the curves. There's 1/4 and there's 1. So going back to the question, it's asking you to find the area between those two curves from 1/4 to 1. There are two situations, two scenarios. Okay? Because if you look at the green scenario, we'll talk about our f of x and g of x, right? According to the green scenario, what's my top curve? What's my top curve? I mean, it's hard to tell which is which, but which is the straight one? 4x or 1 over x? 4x, okay? It's linear. So, in the green area, which is my top curve? 1 over x or 4x? 1 over x. Okay, so this is the green area. G for green. Therefore, my g of x, the bottom curve here, okay, is the 4x. So that's the situation, okay, that's the situation from 0.25 to my intersection point, which I've got to find yet. Okay, now the orange part, over orange up here, what's my top curve now in the orange part, Lockie? 4x. Okay, so my f of x is now 4x. My g of x for the orange part is the 4 over x. The 1 over x. So two scenarios. Okay? Is that all right? The missing part of this question now is what's my intersection point? So let's find that. Okay. So menu. Right, let's get out of annotation mode. So now, do we all know how to find intersection points on graphs? Here's a reminder. Analyse graph. Intersection. To the left. Put the little cursor over to the left. To the right. Bit of Beyonce there, Daniel, you get that? Thank you. Cracked that joke before. So, intersection point is 0.5. Alright? 0.5. Intersection point is 0.5. Here it is here. 0.5. So, I've got two different integrals I've got to work out. I've got the integral, okay, from 0.5 to 0.25, 1 minus x, so that's f of x, minus 4x, so that's my first integral, okay. The other one, this scenario here, is going to be the integral from 1 to 0.5. This time they've swapped over. It's 4x minus 1 over x. Can you see how it's two separate integrals? To find this area here. Remember what area we're working out? It's the area between the curves. That one plus that one. Two separate integrals. Because f of x and g of x swap over. Can you see that? Okay. Now we still have to do it, of course. Better write these on the board because so here it is. Here's our two integrals. Integral of 0.5, 0.25, 1 over x minus 4x, plus integral 1 to 0.5, 4 minus 1 over x. They're the two integrals. So let's do them in the calculator. So we want a new page, calculator page, add calculator. So menu, calculus integral. So 0.25, tab 0.5, and we want 1 over x minus 4x. 1 over x minus 4x dx. Then, put a little space in here. Oops, not there. Then we want plus the other integral. So menu, calculus, menu, calculus, integral. The other one is 0.5 to 1, 4x minus 1 over x dx. Does that look all right? Enter. 1.125 is our area. That's the same as 8 on 7. Anyway, 1.125 square units. Is that cool? Just going back though to the graph so we can see it again. Two separate areas. They've got to be worked out separately. This one's on top of this one, and then this one's on top of this one. And the terminals are different. Alright? So when you get to number 8, purely calculate it. The whole lot. Drawing the graph. Intersection points, don't care. You can do them the long way if you want. But I really want to practice because they are going to be in the calculated section. There'll be an area just like that. About that level of complexity. So number 8 is really important, as is number 6. Let's see how we go. Rest of the lesson is yours. Half an hour. Let's go.